Okay, so I'm just admitting students and then we'll start, right? Let's just wait for 2 more minutes and then we can start. Mansi, you want to say something? You've raised your hand. Mansi Tyagi.
Sorry, ma'am. Good afternoon, ma'am. I was just thinking what this new feature is. So this time I came to able to understand that this is means raising hands.
Okay. So this is if you want to ask some question and you don't want to interrupt in between, then you raise your hand, right?
Okay, ma'am.
Okay.
It's new feature now, so that's why I was confused.
Okay. So what are we going to do today? Let's start the class. So what are we going to focus on today is the common bus systems. We have already talked about the different kinds of registers in the last class. So I hope all of that is clear to you. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
good. Good. I'll just take a minute more to delve into that, and then we will proceed on to the bus system. Okay, we'll look at the common bus system today. Please tell me when you can see my screen. Okay. Is my screen visible to you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. Okay. So let us just go over the type of registers that we did last time. So if you remember, we said that we are going to be following the basic computer laid down in M. Morris Mano, Computer System Architecture by M. Morris Mano, which happens to be a textbook. And according to that, we have a 4096 cross 16 memory. We understood last time that, what do we mean by this 4096 cross 16 memory? And then we saw all these registers. We saw all these registers, which are a part of the register set, which is contained inside the CPU, right? So what are these registers? Let us look at them once again. The first one is the data register. So what does the database register do? Anybody who can answer
Ma'am,
that?
data.
Hmm.
Ma'am, it holds the data which comes to perform a operation.
Very good. So the basically the operands reside in the data register. Okay, so whatever data I have to perform an operation with is put into the data register. Okay, the next is the address register. Address register, who will tell me? It is also sometimes known as
Memory address
Memory
register.
address.
very good.
Memory address
It
register.
stands for, the acronym for which is MER, and it holds the address which we want to access from the main memory. That is the RAM. Is this clear? Right? Next is the accumulator. So, what is the function of accumulator? Who will
It
tell me?
performs the operations.
Hmm. What
It
op?
Similarly, like ALU.
Sorry, come again.
Similarly, like ALU. Quite similar. It performs
No.
operations.
It does not. See, this is one thing that I cleared in the last class also. It does not actually perform operations. It holds the operands and is instrumental in helping to provide to perform the operations. Why? Because it works directly with the adder and logic unit of the ALU. Okay, it works directly with the adder and logic circuit of the ALU. It is attached directly to that. So I told you implicitly AC is called, implicitly means we don't even, somewhere there are some places where we don't even need to spell the name of AC, and actually inside AC is being used to perform those operations. It is being used to help to perform those operations, because all the operands that the ALU is operating upon, they reside in the accumulator.
So,
Okay.
ma'am, basically it holds the operand.
Yes, that is the only function of any register.
Okay, ma'am.
So AC also. But why is it special? It is special because it is the most frequently used register. Okay, it is used directly with the ALU. Okay, so uh, we can say that no operation generally. Okay, most of the operations we can say that no operation happens without the help of AC. Okay, but saying technically that AC performs the operations is wrong, because it is not a circuit that can add, that can subtract, that can perform logic operations, right? So its basic function will not change. Now it is a memory unit. Yes, it is a kind of a register only. Yes or no?
Yes, ma'am.
Good. Okay. So the next is the instruction register. Who will tell me? Please
Ma'am,
speak
may I?
your name. Yeah.
Ma'am, in instruction register, the instruction which we instruct to computer to do specific task is being stored.
Hmm. Actually, yes. So we had said that all our data and instructions in the form of, let's say, apps or programs or softwares, they reside upon the hard disk. Yes or no? There's somebody, just pardon me for a minute. Somebody wants to join in. So Ash, you are late. Ash Agarwal, you are late. Please join on time next time onwards. Okay. Okay. So all the data and programs, they reside initially on the hard disk. From there, they are taken to the main memory. And now, when we want to execute the instructions which we have taken to the main memory, obviously we first need to bring them to the memory of the memory which is inside the CPU, which happens to be the register set. So this instruction, when we bring it down from the main memory, in which register will we bring it in? We will bring it in the
Instruction
instruction
registers.
register. Is this entire chain clear to you?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Very good. Next is the program counter. So please introduce yourself and then tell me the answer. Who will tell me?
Ma'am, can I?
Ma'am,
Yes.
my name.
Okay, Chainika. Yeah.
Ma'am, the program counter, its function is like if there are a set of instruction or code, so it stores the address of the next line of code
Next
or
instruction. Next
instruction.
instruction. Yes.
Instruction.
Yes.
So that's
Yes.
it.
So the program counter holds the address of the next instruction to be executed. Okay.
Yes, ma'am.
Next is the TR. TR stands for? Who will tell me? Yeah. Next. Who was trying to answer earlier? What's your name?
Disha, ma'am.
Okay, good, Disha. Yeah. Tell me.
It is a kind of rough register which acts as an intermediate.
Yes, it is a temporary register. So it can be used to hold intermediate computations, intermediate results. Okay. Next is the input register.
Ma'am,
Yes.
can you explain program counter once again?
But a program counter is basically an address register only. It holds the it is used to hold an address. Okay, but address of what? Address of the next instruction, which is to be fetched from the memory so that that can be executed. Okay,
Okay, ma'am.
is this clear now? So that
Yes,
is why
ma'am.
we say that PC by definition holds the address of the next instruction to be executed. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, good. Now, what is input register? Who will tell me?
Ma'am, me, can I?
Yeah, please introduce yourself.
Ma'am, I'm Dipali.
Yeah,
Ma'am, whenever we input something on keyboard, any character, it directly goes to this input register,
very good.
and that input character it holds.
Very good. So this input register, it serves as an intermediary between our computer system and an output device. So from the output device, it accepts a character. We are saying a character here because the length of our input register is only 8 bits. So 8 bits corresponds to generally one character in most of the programming languages. Okay, so one character is accepted from a input device into the input register, and then that is passed on to the accumulator, and then that is passed on to the accumulator. Nikita Day, next time I'll not admit you this late. Okay, please join on time. Is this clear, beta? Next is the
Yes, ma'am.
output register. Who will tell me about the output
Ma'am, may
register?
I? May
Yes,
I? Ma'am,
name.
whatever output CPU gives us, it first stores inside the output register. After that, it is shown by the output device.
Yes, yes. So whatever output has to be passed on to an output device is first put in the output register, let's say byte by byte or character by character in our case, because again the length of out register is just 8 bits. So that is put in the output register, from where it is passed on to the output device. Is this clear? The functions of all the registers are clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now we had also discussed why should these registers be of a particular length only. Depending upon the configuration of the main memory, which in our case happens to be what? It happens to be 4096 cross 16 memory. Yes or no?
Yes, ma'am.
Yes,
So we
ma'am.
had
Yes.
agreed
Yes, ma'am.
that in this kind of a memory, there are 4096 locations, yani ki addresses, and each address is capable of storing 16 bit of data, right? Now, we had also calculated that this means that we need 16 data lines. Okay, that means 16 places to store these 16 bits, obviously. And to access this memory, we require 2 raised to the power of 12. These are actually 2 raised to the power of 12 locations. So we require a 12-bit address. This is clear to everybody?
Yes, ma'am.
So accordingly now, the registers that handle the data, that is, which all registers?
Data registers,
Very good.
instruction register,
Very good.
And
accumulator,
accumulator.
and
Accumulator,
last
and
one
also
is
the
temporary
register.
register.
All these registers should be of 16 bits so that they can hold the content of the memory, which is 16 bits long. Matlab, it will either be a data or it will be an instruction, but whatever it is, it will be 16 bits long. Since that would be 16 bits long, so these registers have to be 16 bits long. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. So we are left with two registers now, the address register and the program counter. Both of these registers hold addresses, and therefore they must be 12 bits long in our case. Yes or no?
Yes, ma'am.
Because we had decided, we had calculated last time, and we had contended ourselves that to access a 2 raised to the power of 12, that is 4096 address memory, we need 12 bits. Okay. Now let us come to the common bus system. After the revision of the last class, let us come to the common bus system. So what you see here on screen is the common bus system. Now, first of all, what is the use of this common bus system? Please see, we have already said that, we have all these registers, 8 registers that we have discussed in total. So these registers must be able to communicate with each other in the sense that we should be able to transfer the contents of one register to another. Yes or no?
Yes, ma'am.
And,
Yes, ma'am.
and we have again and again said that we want to put we want to fetch the contents from the main memory into one of these registers. Yes?
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
And then maybe perform the operation and then go and store back the result from one of the registers to the main memory.
Yes, ma'am.
So this is clear that we want interconnections between these registers and themselves. They have to be interconnected within themselves and also to the main memory unit. Yes or no?
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
To facilitate the data transfer. Okay.
Yes,
So
ma'am.
now one simplest way to connect these registers and memory could have been that I could have given a single dedicated communication link between one register and all others. So from AR, for example, to all other registers, then from PC to all other registers, then from DR to all other registers. Yes or no?
Yes, ma'am.
But
Yes, ma'am.
you see, in such a system, it would be very complex. First of all, if we increase the number of registers. Yes or no? Even for 8 registers, the number of connections will become very large. Yes. So when eventually this is going to be implemented as a circuit with the help of some wires and all. Yes or no?
Yes, ma'am.
So the
Yes,
greater
ma'am.
the number of wires, the more complex the circuit, very difficult to understand the circuit. Yes. And then if some wire goes wrong somewhere, has to be replaced, or has to be reconnected to some other place later, then it will become a very big difficult job. Okay.
Yes, ma'am.
Yes, ma'am.
Good. So that is why we resort to something known as a common bus system. So this is, if I give you an example, this is akin to saying that since all of you have to come to the college, okay, then we make a dedicated road from each of your houses to the college. Isn't it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
You can just imagine if we had a single road, you know, which connected directly our houses to our colleges.
Mm-hmm.
Okay, what would be the state of the overall roadways of the entire state? Yes,
Yes,
how
ma'am.
complicated, and eventually it will not be manageable anymore, right? So that is why what we do is we lay down some common roads. For example, in a city there is a road which is called as the ring road, okay, to which then individual smaller roads connect, which connect to your houses. Yes or no? Just to give you a broad example.
Yes, ma'am.
Yes, ma'am.
So on the similar lines here, we design what is known as a common bus system. So what you can see here is, first of all, there is a memory unit in between. Placed in the middle are all the registers and the memory unit. And then there is this bus system, okay? There is this bus which is running outside on this periphery. Can you see this? Can you see the
Yes,
mouse
ma'am.
pointer?
Yes, ma'am.
Yes, ma'am.
Now, we are calling this as a common bit, a 16-bit common bus. 16-bit common bus because the maximum number of bits that we require to carry on it at any given time is 16 bits. Because what is the maximum unit of data that I'm going to transfer? It is 16
16
bits. That is the largest length of my registers, and that is the largest amount of data that I'm storing at any given location in my main memory. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Very good. Now let us start focusing on this diagram a bit more. Okay. So the first thing that you see here with these registers is some inputs here. Okay. So what you can see here is some inputs here. What are these? These are known as control inputs. What are these? These are known as control inputs.
Control unit.
So yes, control inputs. Okay. So the memory unit has two control inputs, namely read and write. Okay. Now, when I enable the write input, we will be able to write onto the memory unit. We will be able to write
Right
onto
on memory.
that means we will be able to store something inside the memory. When the read input is enabled, then we will be able to read something from the main memory. Okay? Clear?
Yes, ma'am.
Similarly,
Yes, ma'am.
good. Similarly, there are three inputs that you will find are attached to most of these registers, which happen to be AR, PC, DR, AR, PC, DR, AC, and the TR. Okay. Now, what are these inputs? Let's please see. The first of these control inputs is load. Okay, it is load. So whenever anything is to be transferred into a particular register, let's say in this case AR, then we will enable its load input. Okay.
Okay.
In other words, I can say that when the register whose load input is enabled will get the input. Okay.
Yes,
That
ma'am.
means it will receive the data.
Hmm.
Is this clear?
Yes, ma'am.
Ma'am, can you explain once more?
Yes, ma'am.
Yes.
Yes, ma'am.
So whenever some data is put into a register, that means whenever some data is loaded into a particular register, we first need to enable its load input. Is this clear now?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. The next control input is the INR. INR stands for increment. Okay, it stands for increment. So what do we mean by increment? So suppose the content of address register is all zeros, and I say increment, it will increment it by 1. By default, increment increments the contents of the register by 1. Any problem here? So
No, ma'am.
it is similar to the operation that you do in, let's say, your C++ Like, you have a variable x and you say x plus plus.
Yes, ma'am.
Okay. The next is clear. So clear input simply clears a particular register to which it is attached. Okay.
Yes, ma'am.
Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Please note here that there are two registers here. One is the instruction register and the other is the output register, which only have the load input, which only have what? They only have the load input. So I want you to think about why it is so, and I'll come back to it. Okay. So in maybe next 2-3 minutes, I'll ask you, why do you think it is so? Okay. Now let us look at some other control inputs which you see on the diagram in the form of S0, S1 and S2. Okay. Now these control inputs are known as select lines. What are they known as? They are known as select lines. And these are the control inputs for the bus. So what do they do with the bus? What do they control in a bus? Please see.
Ma'am, movement of data.
Yes, please see. We just said that the register to which we want to transfer the input, okay, we enable its load input. So that is clear. So, if I want to transfer some data into the data register, what will I do? I will enable its load input. Yes or no?
Yes, ma'am.
That is how the data which is on this bus, will go inside the data register. Okay. But how will the data of a particular register, let's say in this case DR, be placed on the bus? How will it be placed on the bus? So for that, what we have done, we have agreed upon an arrangement that whenever I say 1, then it should mean AR. Whenever I say 2, then it should mean PC. Whenever I say 3, it should mean DR.
Data
4
register.
AC, 5 IR, 6 TR.
Yeah.
Okay, is this clear? So,
Yes, ma'am.
so we have agreed upon this, and 7 would denote the memory unit. 7 would denote, the number 7 would denote the memory unit. Okay. Now, whenever I want to select then AR, what do I do is I put the equivalent binary digits of this one, okay, which happen to be 001, yes or no?
Yes, ma'am.
Which happen to be 001 on these 3 selection lines. Okay, so I'll put S0 is equal to 0, S1 is equal to 0, and S2 is equal to 1. Okay, when I put this here, then which register is selected?
AR.
AR is selected. For what? For output. Okay, for output. Because if I wanted to select AR for its input, I would have simply enabled its load here. Yes or no?
Yes, ma'am.
Yes, ma'am.
Is this
Yes,
clear?
ma'am.
Can you
Yes,
explain
ma'am.
it once again?
Yes, I will. So please see, I'm revisiting this again. All of you, please see. So we have placed these registers in middle, and you can see that there are only 2 jobs to be done here. One is that these registers accept something from the bus. Yes or no?
Yes, ma'am.
Yes, ma'am.
And the other is
Yes,
that
ma'am.
they put something on the bus.
Yes, ma'am.
Yes or no?
Yes,
So
ma'am.
suppose I wanted to transfer some information from the data register to the temporary register. How would it happen? the contents of data register would be put onto the bus, and then they would be put onto the, from the bus they would be put onto the temporary register.
Temporary register.
Yes, ma'am.
And because they are not directly connected, we had said that we are not connecting them directly, we are connecting all these registers and the memory unit through the bus. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Okay. So now how to get the data from the bus into the registers? We have already seen. How will we get that?
By enabling the load.
Load.
By
Enabling the
enabling the load of that particular register. Yes or no?
Yes, ma'am.
yes, ma'am.
Yes. So this part is clear. So whatever data comes here, to which register it will go? To which register it will go? It will go to the register whose load is on. Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Now the only thing that is left is that if I want to place the contents of some register onto the bus, okay, then how to do it? There is no control input for that. You can see that. है ना? So how to do? We use these selection lines for this purpose. So we have agreed upon some decimal number for each of these, unique decimal number for each of these registers. We have associated these numbers with these registers, and I translate it into binary and put that number here. Whenever I put that number here, okay, that register is selected for its output. Its contents are simply placed on the bus. Clear? So if I say 2, then PC's contents would be put on the bus. If I say 5, then instruction registers contents would be placed on the bus. Is this clear or not?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Right. There is somebody who needs to be admitted. Disha Vadva. Beta, how can you join so late? Just give me a second, please. Yeah, so please see. Can you still see my screen?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, good, good. So this is clear now. These selection lines are clear.
Yes, ma'am.
Okay. So there is one more thing that I'd like to show you in this common bus system, which is the adder and logic circuit. Okay. Now, what is this adder and logic circuit? Just give me a second, please. Yeah. So now please look at this adder and logic circuit. This is associated with the accumulator. What does this do? So as I told you, this is the part of the arithmetic logic unit. You know, all the operations that it does, you can see that it directly communicates with whom? It directly communicates with the AC. So AC is not only connected with the bus, the common bus, it is also, its output is also, you can see, going to this adder and logic circuit. Can you see that?
Yes, ma'am.
Yes, ma'am.
Yeah. Now, what is this E? What is this E now? Please see, E is treated as an extended bit of AC. Okay. That means AC is of 16 bits And then the highest order means the leftmost one extra bit is attached to AC as a separate flip-flop, which we call as E. It stands for the extended flip-flop. It stands for the extended flip-flop. Now, what is the job of this extended flip-flop? Yeah, hello.
Yes,
Yes,
ma'am.
ma'am.
Yeah, but sometimes there is a little disruption here because of power or something. So I request you to kindly stay in the meeting. Okay, so it takes the UPS a second or so to switch on, and the power comes back. So I request you to please, whenever it happens, I request you to stay inside the class. Okay. Okay,
Yes,
so
ma'am.
yeah, so let's go
Okay.
back to okay. So we were looking at this extended bit E, and we were trying to see what do we mean by this extended bit E. Okay, so this extended bit E is used to store the end carry. So sometimes when you are adding two numbers, okay, there is a end carry. For example, if I do 5 plus 6, okay, and it is so what do I get? I get 1 1. Okay, so in the 10th place where I was adding, there is a 1. Yes, sorry, in the ones place where I was adding, there is a 1, and then there is a carry to the next position. Okay, so that carry, here we do all the computations in binary, not in the decimal number system. The computer doesn't do it. But even in binary, similarly, there is a end carry sometimes. Okay, so that end carry is stored in this extended bit E. Okay, so
Excuse me, ma'am.
yes,
I cannot see the screen.
Yes, ma'am.
okay, okay. Can you see the screen now?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, beta. Okay. So what is the job of this extended bit E? The job of this extended bit E is that it stores the end carry. Okay, it stores the end carry, right? Now, this is all about the common bus system, except that we need to talk about one more thing, which is clock here. Now, what does the clock do? You can see there is this input of clock which is attached to all the registers here. Yes or no? Can you see this?
Yes, ma'am.
Yes, ma'am.
Yes,
Now, what
ma'am.
is the job
Yes,
of
ma'am.
this clock? What is the job of this clock input? The clock input is very important because it synchronizes the entire system. So otherwise, you see, these are individual registers, but when we apply clock input to them, they behave like a system. Why? Because they can operate only when we send a clock signal to them. Okay, so let's say this time instant is the time instant t0. Okay, so whenever an operation in this bus system will be performed, it will always be performed with respect to the clock signal. So only when I send the next time signal will some operation take place. That means even if I have enabled the load input of some particular register and there are some contents which have been placed on the bus, still those contents will not be transferred into that register unless and until the next clock pulse is given, unless and until the next clock pulse strikes. Is this clear? Beta, is this clear?
Yes, ma'am.
I'll repeat. Should I repeat?
Yes,
Yes,
ma'am.
ma'am.
So basically, what is the job of the clock signal? Please see, what is the job of the using time? Okay, students, I'm sorry for the interruption. Let us complete. So what is the importance of the clock pulse is that it synchronizes the entire system. That means whatever operation happens in this system happens always with respect to a clock pulse. Okay, so for example, if we did not have a common meeting time for all of us, then what would happen? One student will come to the class at some other time, the other one would come to the class at some other time, the third one would come to the class at some other time, and I will come to the class at some other time. Yes or no? Then the class would never be possible if we did not set a common meeting time. Yes or no? When we set a common meeting time, we behave as a class, we behave as a single unit. That means everybody individually joins at the same time and then the transfer happens. Okay, yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So That is why we have a clock system here. So what happens here is that when the clock is connected to all the registers, all the operations happen only with the striking of the next clock pulse. Okay? They only happen with the next clock pulse. So Astha Vishnoi is trying to join in. She wasn't joined in earlier, no?
Ma'am, excuse me.
Yeah, tell me.
Ma'am, your screen is not visible.
Okay, I'll just start it. Astha, is this the time to join? Next time I'm not going to allow anybody who's more than 5 minutes late. Okay? This is for everybody, please. Is the screen visible now?
Yes, ma'am.
Okay. So the idea behind putting a clock is that we are all able to, put in the contents from the bus into the registers at the same time. So the entire unit looks and behaves as a system, complete system, which works with at the same time. That is the importance. Okay, so next class I will be, revising. We will be revising the registers in the common bus system. Once again, we'll have a recap, and then I'll discuss with you certain questions which will be based upon this common bus system and these concepts of the main memory and the data lines and the address lines that we did in the last class. Okay, so from the they will be important from the point of view of your theory exams as well. Okay, so next time I'd be doing questions from your book, some question from your book, uh, which will be based upon these concepts. Is this clear?
Yes, ma'am. Excuse me, ma'am.
Yes, tell me.
Ma'am, I wanted to ask that in this bus system diagram, what is this write and read under memory unit?
Beta, I already told you. So please see, uh, the corresponding number to the memory is main memory is 7. Okay. So when I put 7 here in binary, which is 111, okay, then memory gets selected. Okay. Now memory is now selected. Now once memory is selected and I enable its write input, then whatever are the contents of the bus at that time, whatever are the contents which have been placed on the bus will be written on the will be written to the main memory. Okay.
Okay.
And suppose I had put 111 here and I had enabled the read input. Okay, then whatever contents from the main memory, are there at this register, which are in the at the address, which is there in the address register, would be put onto the bus.
Okay. Okay.
You can see this input from the address register going to the memory unit.
Yes, ma'am.
Yes.
Yes, ma'am.
Now, just one more thing before I finish the discussion of the common bus system. That is these two special registers that you see here, input register and the output register. So you can see that input register actually is not connected to the bus directly. Can you see that?
Yes, ma'am.
Yes, ma'am.
This is because it does not have to receive its input from the bus. That is right or wrong?
Yes, ma'am.
Right. We had said that it will receive its input only from the input device.
AC.
Yes. So you cannot see any connection here from this side of the bus to the input register. Similarly, we had said that the job of the input register is to pass on to accept a character from the input device and pass it on to the accumulator. So the contents of the input register are not for any other register. Okay, so it does not put them on the bus. Okay, so as a result, it has no output connection to the bus. Rather, its output is directly connected to the one, it is connected to the adder and the logic unit. Okay, from where the whatever operation has to be done is done and it is passed on to the accumulator. Is this clear?
Yes,
Ma'am,
ma'am.
what is this adder and logic?
But I've already told you this is the adder and logic circuit of the ALU. Adder and logic circuit of the ALU of the CPU.
Okay, okay. Okay, ma'am.
Then next, let us look at the output register. So this output register, please see, it has to take the input from the bus and then place it onto the output device. So its output is not connected to the bus. You can see that? Yes or no?
Yes, ma'am.
Only the input of the output register is enabled, and therefore it also has only one control input, which is the load, which can help it to take input from the bus. So whatever output we want to display on the output device, we put it on the bus, okay, and it goes to the output register by enabling the load of the output register. After that, the output register passes on that information to the output device. Is this clear? It does not have the functions for increment and clear because it doesn't require them. Okay, it cannot change. It should not be able to change the output before it passes it on to the output device. That is why it does not have the input, the increment and the clear control inputs. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. Now the other register which does not have the increment and clear control inputs is instruction register. Even the instruction register only has the load input. Why? Because the instruction register does not have to and should not be allowed to change the contents of the instruction. Yes or no?
Yes, ma'am.
Is this clear to everybody? Can I hear a yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, it's clear.
Yes, ma'am.
Okay,
Yes,
good.
ma'am.
Good. So this is the common bus system. So in the next class, we will look at a revision. We will first revise all this, okay, and then we will go on to do some questions which are based on the topics that we have discussed up till now. Okay.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
So I'll share a link for your attendance. Please mark your attendance.
Okay, ma'am.
Excuse me, ma'am.